All right, welcome everybody. So today we're going to talk about inter-VLAN communication. Inter-VLAN communication is important. Why? Because if you once you create your different VLANs, they're not going to be able to talk to each other. Now, as far as CCNA certification, they just want you to know how would you configure inter-VLAN communication, right? Or inter-VLAN routing. And that will be creating sub interfaces on a layer 3 device. It could be on a switch, a multi-layer switch, or on the router in our case. Now, some of you may be saying, well, that kind of defeats the purpose, right? We don't want VLANs to communicate with each other. We weren't doing it for security reasons. We're doing it for broadcast reasons. That's why we created these VLANs. So, what happens in the VLAN stays in the VLAN. We want to secure it where one VLAN can talk to another. And that's true. But we need to take other measures in order for that to happen. If you don't create inter-VLAN communication or inter-VLAN routing, you're not going to be able to get anywhere. Period. End of story. Because the VLANs that we create, like VLAN 10 and VLAN 20 that you see there in the blue or the green, VLAN 10, VLAN 20, cannot go across this particular port right here because this port, number one, is off. We haven't done anything on the router to turn that on, right? And number two, it's not trunked. I have not trunked this port because VLANs that we create must be trunked. And the trunking protocol that we use is the 802.1q. Okay? So that needs to happen. Here, VLAN 1, which is the shares, they won't be able to access the shares because they can't get across. And this is the reason why. All right? Because one, they're in a different network. All right? And two, they got to go across trunk ports because they don't know who they are. They don't know that they're VLAN 10 or VLAN 20. They must be frame tagged. So when you start creating VLANs, which is a recommendation, which is a strong recommendation, which is something that you need to do on a network, you need to logically segment your network. You do need to create inter-VLAN communication or routing in order for VLANs to talk to each other for the ones that you want to talk to each other. But that's then doing other things like doing pruning. You're allowing certain VLANs to talk to another. That's a whole nother story. So right now, we're just going to go ahead and configure inter-VLAN communication. So one of the first things that I'm going to do so I don't forget is I'm going to go to G01 and I'm going to go ahead and trunk that port. Okay, and this is a 3560 switch, so it's two commands. I'll show you what I mean. Here you can see that I've created VLAN 10, that's counting. I've assigned it to ports 1 and 2. VLAN 20, which is sales, I've assigned it to ports 3 and 4. The server is in port 5. He's part of VLAN 1. Therefore, he's already there. He's in VLAN 1. That's the default VLAN. That's where the shares are at. All right. So what we're going to do is trunk G01. Okay. So we're going to go to config T, interface G0/1. Now, if I try to do just this, switch port mode trunk, which is what we normally do on a layer 2 switch, or on a 3650 switch, and on 3560, it's two commands. We have to do switch port, trunk, encap, .1q. We need to choose the type of encapsulation, trunking encapsulation that we're going to use. For certain switches, ISL is still a thing, all right, in their iOS. So you need to choose the encapsulation method. We all use .1q. And now I'll just up arrow to that command, switch port mode trunk, do WR. Beautiful. Now that port is trunked. So now we're going to go to the route. Now, I'm sure that we've been taught, right? And whatever school you go to, all right, let me put this right over here. Whatever school you go to, they've taught you certain ways that they want you to create inter-VLAN communication. And this is the way that I was taught as well. Okay, enable config T. Let's call this host name R1. Okay, you go into the interface and is G00, it's right there. Interface G0/0, and you just turn it on. You just turn it on. And then obviously we have to create sub interfaces per VLAN. Now you could create a sub interface for VLAN 1, and that's fine. But VLAN 1 does not need, you don't need to tell it that we're using .1q. VLAN 1, the native VLAN, the administrative VLAN, the whatever you want, management VLAN, whatever you want to call it, VLAN 1 by default, right, which is the native VLAN, can go across access ports or trunk ports. So you really don't need to put it under a sub interface. For this example, we will, but there's no VLAN 1, the native VLAN. You don't need to do that because it has the PVID, a port VLAN identifier inside it, so it knows who it is. Okay? But in this example, we're going to do it. So just the very basics. This is the very, very basics and how they teach you, right? Even in the Cisco Networking Academy. So what we're going to do is we're going to do up arrow, and we're going to create subinterface 1. I can create whatever subinterface I feel like. That subinterface number means, technically doesn't have anything to do with nothing. It's not pointing to anything. Or it's for visualization purposes. So when you look at that subinterface, you're going to say, oh, that's VLAN 1. Okay? So let's just do it that way. Once you do a subinterface, the next command that you must type, is the encapsulation type. It will not allow you to put the IP address. And I'll prove it to you. IP address. It'll be great since this is a new version of the packet tracer that it'll say, oh, it's okay. 192.168. This is your gateway address, 254.255.205.205.0. It's not going to do that because it needs to know the type of trunking that you're using, 8021Q or ISL. So we're going to do encap.1Q. Here, it's going to ask you for a VLAN identifier. Here, you need to do VLAN 1. Here, it must be 1 because that's the VLAN you're trying to communicate with. So that's 1. Now, you can go in there and put in your gateway address. That's fine. All right. So now we're going to up arrow through our commands. So now we're going to go to VLAN 10. Okay. VLAN 10. There it is. Just a number, but visually I know that's going to be VLAN 10. Then we're going to do our encap. I'm going to up arrow, right? And just add a 0. There it is. That's encap.1Q. That's the VLAN I want to communicate with. All right. What's its gateway? I'm going to up arrow. You need to learn how to work quickly, efficiently. Pay attention to detail. All right. There you go. You got the sub interface right here. You got the encapsulation type and the correct VLAN. And you have your correct gateway. All right. Now we're going to go to sub interface 20 because VLAN 20. Yeah. And then we're going to do the encapsulation 20. And then the IP address, change the 10 to a 20. And I'm done. DWR. Not so difficult. Not so difficult. The configuration is not difficult. What's difficult is like finding out, okay, why is it not working? The majority of times that it's not working, let me do a show start. This is right there. We're going to see that. So you can see that this, I put that 1, but it knows I'm talking to VLAN 1, and VLAN 1 right now is the native VLAN, so that's why that's there. Then, and there's a method to my madness where I put 1, 1, 1. So I make sure that this is correct, right? That the sub interface is pointing to the correct VLAN that's going to be in that particular network. And my gateways are always my last available IP address. Now, on a testing environment or sometimes in the field, everybody uses whatever gateway it is. Make sure you put in the right gateway address. All right. And make sure that you do have the right encapsulation. So if I were to put here, let's say for VLAN 10, just looking at this, I know that's going to be VLAN 10. And here's telling you that that's the VLAN you want to communicate with. An issue that could happen is that you put in here 11, or you put here 20 or 30 or 40 or what, any other number than 10. Or you put 1 and you thought you typed 0, but you didn't. So then that becomes an issue. That becomes an issue. Okay? Wrong encapsulation type, wrong IP addressing. The sub interface that you create, nothing. It means it's just for your visualization. But if you put the wrong encapsulation type, you put the wrong gateway, you're not going to get connectivity. All right? And then we have the last one, which is 2020. Now, to troubleshoot, I'm going to come to the PC. So let's go to VLAN 1. All right, I'm going to go to the command prompt, and I'm going to say ipconfig right? I can see that I have my 192.168.1.1, and there's my gateway, right? So I'm going to ping 192.168.1.354. All right, I'm good to go. I can ping my gateway. Can I ping anybody else? 192.168.10.254. That's their gateway. And I can. Can I ping the 20.254? And I can. All right, so if I'm there, can I ping, can I ping 10.1? That's a host on that side. Obviously, ARP, okay? This is why we don't want to use IP4 anymore. So I can ping 10.1, 10.2. Again, ARP. Who's 10.2? Oh, that's me. Okay, there you go. Control C. Can we do it to 20? Oops. So from one location, you can do all your troubleshooting. You can ping your gateway and you try to ping all the way out. All right, and you see that you get a reply. All right, and then 20.2. So if you're now communicating across the entire section, right? All the VLAN. Obviously, you do want to put security on here. Okay, what happened here? Taking way too long. All right, I was able to ping the gateway. Let's see if I didn't put an IP address on that. So you saw I was getting request timeout. Sometimes it takes too long. I have zero patience. Okay, you see, I didn't put an IP address there. So 192.168.20.2 tab 192.168.20.254. All right, click close. All right, minimize that. Let's fast forward through time. Let's go in here. It's my favorite button on the packet tracer. Let's go to the command prompt. Okay, you see you got your 4 request timeouts. And let's see what happens now. There we go. And now we can ping. It was just a matter of that I forgot to put an IP address. And when you're troubleshooting, always go for the easiest stuff first. The cable's plugged in, you don't have an IP address, are you pinging the right address? Things like that. All right, take a look at the router. And it's only working because that port, G01, you go back inside the switch into a show and trunk. All right, it is trumped. That is, you verifying there's a trunk port. And you see that VLANs allowed, all of them. All the VLANs are allowed. And you see VLANs allowed and active in the management domain right here. Okay, and they're not pruned. They're not pruned. So you're not pruning anything. You're not restricting any VLANs from being able to communicate. So this could be a realistic scenario. If you look at a dentist's office, a doctor's office, a small accounting office, a tax office, something like that, like in a strip mall, whatever, in a very small network, you can have a wired network like this, where one particular switch, 24 port, 48 port switch, you can divvy it up into different VLANs, right? Everybody has their own little responsibility, right? It could be a group of people, right? These are, 2 people in this particular department, the accounting, 2 people in sales. This is just a default VLAN where it's going to be my shares that they need to access. It could be I could put another VLAN. It could be VLAN, let's see, 10, 20, 30. And that could be for HR. Or it could be for whatever. I mean, it's a small company. It could be the boss. Call it whatever you want. But, or you could have a wireless network within that VLAN. You put an AP out there and they can connect to that particular VLAN in wireless. So these are the kind of things that you do with VLAN. You logically segment your network and then you have them communicate with each other. Because if you don't do that inter-VLAN communication and you do not trunk this port right here, yeah, VLAN 20 and VLAN 10 aren't going anywhere. VLAN 1 can go anywhere it wants because they can go across trunk or access ports. Does not matter. Now, in your definitions in your books and your professors that tell you in the Cisco Networking Academy that trunk ports are there because you want to, their purpose is to have multiple VLANs go across, which is true. And that's where they get their name in telecommunications that has all these lines going through there, these trunk lines, right? But the bottom line is, yeah, all the VLANs go through a trunk port, but it's because they need to get framed tagged. Because once you create a VLAN, it has no identity. It doesn't know who it is. it has to go through the trunk port, and then the trunk port will tag it as VLAN 20, VLAN 10, VLAN 30, VLAN 40. The native VLAN will, whatever number that may be, by default is VLAN 1, has already that PVID number in it. Okay? So that's an example of inter-VLAN communication, the syntax, the configuration behind it, and then verifying it. Very easy to do. Don't forget on the test, just nice and easy. Ping, see who you can ping. Always go for the easiest thing. Check IP addresses, and then check trunk ports. Check trunk ports. That 9 out of 10 times, that right there is the culprit. Or you could have assigned it to a raw VLAN as well. All right. With that said, I'll see you in the next one.